A new paper from Google, MIT, and University of Illinois just proved that giving a small AI the right kind of memory makes it smarter than a model literally 100 times bigger. And if you've ever built an agent with Claude Code, Cursor, or any AI tools, this changed how you should think about everything. Let me show you. I'm going to break down a paper called SkillOS. By the end, you'll understand why this might be one of the most important shifts in AI agent this year, how it connects to the way you already build with AI, like writing CLAUDE.md files or .cursor rules, what the actual numbers looks like across multiple benchmarks, and how you can steal these ideas for your own projects right now. Let's get into it. You've used Claude, you've used Cursor, you vibe code in an app over a weekend, and you definitely notice something weird. The AI keep making the same mistakes. You teach it your code base, you fix a bug, you explain a pattern, and the next session, it's like meeting with a brilliant stranger who happens to have amnesia. Researchers call this one-off problem. Every task starts from zero. The AI doesn't actually learn, it performs. For one-shot questions like write me a function, that is fine. But for real agents that do dozens of hundreds of tasks over time, it's a disaster. They waste tokens, they repeat failure, they never get better. We've all been hacking around this. We write CLAUDE.md files, we ping context, we build .cursor rules. We're basically hand curating the AI memory ourselves. And it works, kinda, but it doesn't scale. So the question the SkillOS team asks is, what if the AI could just do it for itself? Let me explain this in plain English because the paper is dense, but the core idea is beautiful. SkillOS is a research framework from three of the biggest names in AI: Google Cloud AI Research, the University of Illinois, Urbana Campaign, and MIT. Their goal is simple: teach AI agents to learn from their past experiences, kind of like how humans build up skills over time. Here's how it works. Instead of solving every task from scratch, the AI maintains its own skill library. They call it the skill repo, and this library is just a folder full of markdown files. Each file is one skill, stuff like how to verify a math proof or how to recover when an object isn't where you expect it. Real, reusable, plain text knowledge. If you've played with Anthropic's agent skill format, which they released last year, this will look extremely familiar, the same vibe. But now here's the smart part. SkillOS uses two AIs working together. The first one is the executor, that's the worker, the one actually doing the tasks. The second one is the curator. That's a librarian. After every task, the curator looks at what happened and decides add a new skills, update an existing one, or delete one that's not pulling its weight. And here's the kicker. They trained that curator using reinforcement learning. It doesn't just guess what to remember. It learns over thousands of tasks what actually helps the worker succeed later. Quick aside, because the name is genuinely clever, they called it SkillOS because it works exactly like an operating system. Think about your laptop. You don't dump every photo, every doc, every download into a giant blob. You have folders, files. You create new ones, you edit old ones, delete junk, and that's an OS managing files. SkillOS does the same, but for AI skills. 3 operations: insert, update, delete. Just like database, just like a file system, just like an OS. Once you see it this way, you wonder why we've been treating AI memory like a giant garbage bag for so long. If it's clicking, smash that like button, because the next part is the where things get genuinely weird. Here's the experiment. They take a tiny 8 billion parameter open source model, QN3-B, and they train just a curator using reinforcement learning. The executor stays frozen. So they compare it to using Gemini 2.5 Pro as the curator instead. Same setup, same task, just swap the librarian. The 8B model wins constantly. On AlphaWorld, the household task benchmark, the trained 8B curator hits 80.2% success. Gemini 2.5 Pro as a curator, 79.3%. On Webshop, an online shopping benchmark, same story. On math reasoning across AIME and GPQA, same story, 88.6% versus 85.4%. Why? Because raw intelligence isn't the same as knowing what to write down. The 8B model learned through trial and error, what's actually useful for this specific executor. Gemini is smarter in general, but it doesn't know what the student needs. The trained curator does, and that's the whole insight. But here's what really shocked me when I dug into the tables. SkillOS doesn't just help small models. It helps every model, and it gains compound with size. The ALF world paired the trained curator with Q3.8b, and success jumps from 47.9 to 61.2. That's a 13.3 boost. Pair the same curator with QN3-32b. You go from 54.5 to 68.6, a 14.1 boost. Pair it with the Gemini 2.5 itself as the executor, 66.4 rockets to 80.2, a 13.8 boost. In other words, stronger models doesn't need this less. They benefit just as much, sometimes more. And the curator stays the same tiny 8B model the whole time. There's another underrated stat too. Agents using SkillOS don't just succeed more, they succeed faster. On ALF world, they shave 2 to 3 steps off every task. On webshop, same thing. Fewer steps means fewer API calls. Fewer API calls means lower costs. If you're building agents commercially, that's real money. Okay, this next part blew my mind. Almost no one's talking about it. The team ran a test. Take a curator trained only on math reasoning and use it for online shopping agents. Or take a curator trained on household tasks and apply it to math. Cross-task transfer. Here's the wild result. The curator trained on reasoning tasks gives shopping agents a 7.3 point boost. The same curator boosts household agents by 4.5 points, trained on one domain, improving another, with zero retraining. Why? Because what the curator learned isn't really math tricks or shopping tricks. It learns meta strategies, things like verify your answer, decompose the problem, have a fallback plan. Those transfer everywhere. The curator essentially learned how to teach, and that skill generalizes the same way good mentorship generalizes across industries. Drop a comment with SkillOS if you want me to do the follow-up showing how to build your own mini version of this with Claude Code. Now let's talk about why this whole thing actually works. The team did something every great paper does. They tried to break their own system to figure out which pieces matter. They tested 3 versions, removed the content quality reward, success drops from 61.2 to 58.6, removed the compression reward, drops to 16.0. Both meaningful. But here's the big one, remove the group task streams and success craters to 57.3. What are group task streams? Here's the secret sauce. They don't trade a curator on random tasks, they group related tasks together. So when the curator writes a skill after task 1, it can see whether that skill actually helped on task 3 or task 5, tasks that need similar knowledge. That feedback loop is everything. Without it, the curator is just guessing. This is why prior work failed at scale. Most memory papers trained on isolated examples. SkillOS realized the curator needs to see consequences. It needs to know, did this skill I wrote actually pay off later? The team tracked what the curator did over time as it trained, and the pattern is shockingly human. Early on, the AI was a hoarder, smashing the insert new skill button on every task. The library exploded with random task-specific nodes. Then something flipped. Around training step 15 to 20, update operations started rising sharply. The curator stopped just collecting and started refining, going back to old skills, adding failure recovery sections, making them more general, and eventually, the skills themselves got meta. Early on, only about 5% of the library was meta strategies. By the end of training, that jumps to 29%, almost a third. The library shifted from how to find a mug in a kitchen to general failure recovery strategies and verifications patterns for math problems. Junior collection trivia became senior writing internal docs. There's also this beautiful stat, SkillOS used skills on 100% of evaluation tasks. The baseline only used them 87% of the time. But here's the twist, SkillOS uses fewer skills per task. Roughly 2 instead of 2.2. More precise, not more cluttered. Better filing systems, not bigger filing system. If you're a wipe coder, Building apps with Claude Code or Cursor, you're already manually doing what SkillOS automates. Every time you update your rules file, every time you paste "here's how my project works" preamble, you're being the curator. SkillOS is what happens when the AI learns to do that job for itself. If you're building AI agents commercially, it is even bigger. Running a frontier model as a curator is on every task is expensive. SkillOS suggests that you can use cheap, small model and get better results. That changes startup margin overnight and the cross-task transfer finding. That's the real holy grail. It means you can train a curator once on whatever data you have and reuse it across totally different products. One curator, many agents, all getting smarter together. Most AI papers come and go. SkillOS feels different. It's not about making models bigger, it's about making them learn. And once AI agents can actually accumulate experience, once they stop being goldfish and start being apprentices, the whole game changes. If you want me to break down next big AI agent paper or do a build along where we make our own mini SkillOS using Claude Code, comment below and tell me which one. Please subscribe, like the video if this rewired your brain a little, and I'll see you in the next video. Peace.